more about this evolving semiconductor industry in India. Government of India is very active in attracting the multinationals and to promote India as a next destination for semiconductors and IC design.
Semiconductor industry, investors, academics, and friends. Semiconductors are playing a critical role in the world in more ways than we can imagine. It is our collective aim to establish India as one of the key partners in global semiconductor supply chains.
First, we have to learn what is power management IC. Right. So we have consumer electronics, we have inverters, grid-connected systems, renewable systems. So these electronics has to be supplied with power. This is a very growing field because you can imagine that all our systems are electronics intensive.
A little more about how this course is going to benefit our budding engineers and fresh young graduates.
When I was a graduate student, I designed a power supply. I used many ICs to control that converter. What they did was they took all those ICs and made it a single IC. This is exactly what I will be trying to bring out in this course. How do you define an IC?
What is your expectation from the prospective students?
The students will get an overview of how power management ICs are defined and designed. Expectations should be that have patience. Patience is what I am expecting from students and fundamentals what they should expect.
Oh, great. So welcome to this special podcast on the Power IC design. Principal Scientific Advisor to the Government of India in collaboration with IIT Delhi is going to conduct a special certificate level program on skill development program in this niche area, and this will be conducted by Professor Shantanu Mishra, who is a very senior faculty at IIT Delhi. He has a very long and distinguished career both in industry and the academia. He has started his career from Infineon, and now he is into this academia where he not only teaches but also is deeply into the research areas of power management IC design. So sir, tell us a little more about this evolving semiconductor industry in India. Government of India is very active in attracting the multinationals and to promote India as a next destination for semiconductors and IC design. So tell us a little more about this and how this will impact the prospective employment generation in India for our engineers.
Okay, so what you asked is a very big question.
Yes.
The field is very vast.
Right.
So my focus is on power management IC. So I will talk about the answer to the question in the context of power management IC. So first we have to learn what is power management IC. Right. So we have consumer electronics, we have inverters, grid-connected systems, renewable systems. So all kinds of systems are there. They all use electronics, okay, to control and manage their system. So now these electronics, like it may seem that they are very trivial, but they are actually very demanding. So these electronics has to be supplied with power. So power management IC is the business of powering and managing power to this electronic system. Okay, so power management IC is basically anywhere we are using processors and electronic systems in order to power them. Whatever power is required, that is actually taken care by this power management IC.
Okay.
Right. So, and this is a very growing field because you can imagine that all our systems are electronics intensive. So if all our systems are electronic intensive, we have to power them. So therefore power management IC becomes a bread and butter of IC industry.
Right, very nice, sir. Nicely put, sir. So tell us a little more detail about this course structure which you have designed for this particular power management ICs, especially for consumer electronics and the whole system design.
Okay, so see, one of the difficulties we used to face when I was a company man, right, I was in the industry, was getting the right manpower for this type of work. Okay, the reason is that mostly this kind of work requires two different fields. One is power electronics, how to design them, another is IC design concepts. So mostly both the topics are not covered by the same student. So therefore either of the student was hired and they were trained to have the other field. Like if they're hiring a power electronics engineer, they have to train them to do IC design, or they're hiring IC designer, then they have to train them to do power management circuit design. So what this course will be is this like bridging this gap. So what we will try to do in this course is we will try to bridge the gap between a power electronics designer and IC designer and combining them to make a power management IC which will be powering electronic systems. Right. So therefore, as I explained, there will be two parts to the course. The first part of the course will be understanding power management circuits. Like with many applications, we will be telling what this power management circuit is and how to design them, and block level how to implement these ICs. Okay, so and once that is done, in the second part of the course, we will go through the IC implementation of these blocks. Right. So this will be we will try to basically, like I said, we will try to bridge the gap between a power electronics designer and the IC designer, and combine them to make them understand how a power management IC is built.
So if I'm wrong, I'm right in understanding you. So the things will start from the system perspective. Then you will come down at a block level of how the system has the different blocks and how the blocks interact and make it a system. Then again you will go to a little detail and what stands inside that block at the component level. So separately in the IC design, you will be teaching those things also. So block level as well as IC, both things you will be covering in this whole exercise.
Yes, like to elaborate on what you just now said, exactly that is what we will do. So we will start from an application. Okay, so let's say I have to power a cell phone. Cell phone has a Snapdragon processor, so I have to power that cell phone. So I require a circuit because my battery is at 5 volt, but my Snapdragon processor requires a 1.8 volt perfectly stable power supply. Right. So we have to use a power management circuit for that. Okay, so these are called point of load converters. So this power management circuit will consist of two parts. One is the converter part, another is the controller part. Converter part will be component level, controller part will be the IC, power management IC. So in the first part of the course, we will take an example, and from there we will try to explain how to design the converter, how should the IC be to control that thing, and what are the components inside the IC that has to be there, okay, in order to make the controller work. That will complete the first part of the course. Now the second part of the course, what it will do is that it will start from where the first part of the course ends. Like the second part of the course, that we know now what is inside the IC, what are the blocks that are required to design this power management circuit. So all these blocks we will try to design using IC implementation. We'll generally use in this course, I'm planning to use TSMC 180 nanometer process, how to use that process to design this chip.
Very nice. So the components and the level circuits, like for example op amps and diff amps, you will be teaching in TSMC 0.18 micron technologies.
Yes. So we like a system has many blocks. Okay. A IC has also many blocks. If you look at inside the IC, there is an op amp that also has many blocks. So we will see all the blocks and how they are implemented using CMOS processes.
Right. And what kind of softwares you will be using to show the simulations at a system level, sir, when blocks will be implemented? Will it be LT-SPICE or?
Yes, we extensively use LT-SPICE. But one of the interesting fact about the course will be, and maybe you will appreciate being coming from an analog background. See, this course is a power electronics engineer's perspective of how IC works, right? So obviously my knowledge of IC will not be as great as a traditional VLSI professor, right? But I will know enough so that I can design the IC, and that is precisely what is that I will try to bring out from this course.
Nice. Sir, so tell us a little more about how this course is going to benefit our budding engineers and fresh young graduates, and also how people who are already working in industry, they can benefit from this course.
Okay, so it's actually a very interesting question, and I will try to answer it with my journey in this particular field. So when I was a graduate student, I designed a power supply. So how the power supply was designed? There was a converter. I used many ICs to control that converter. Okay. So once I achieved that objective, now there was a company who was interested in making an IC out of all the ICs that I had used. So the type of design that I did are traditionally called off-the-shelf design. That means IC is available in the market. They use those ICs to control a power converter and design the system.
We generally call it COTS, commercially off-the-shelf systems, COTS systems.
COTS systems. Yes. So now once the company was interested in it, what they did was they took all those ICs and made it a single IC. Okay, and they actually commercialized it. It is still commercially available. I designed it for Intersil originally. Now it is available with Renesas, because the technology was bought by Renesas. So this is exactly what I will be trying to bring out in this course. That how do you define an IC? Okay, so the first part of the course will tell you that this is what a converter is, and these are the blocks that are required to control the converter. So how do you design that system using discrete ICs? So once we have done that, then we know in the second part what should we do to make an integrated IC using those individual blocks. So for example, if my general then the first part I will prove that I require a op amp, I require a comparator, I require a ramp generator. So these are discretely made. Okay, and once we have achieved that, then I will tell you in IC how these things are done. Okay, so to come to your question, your why it was an important question was because the answer that this course will try to give is that at the end of the day, we have to define those ICs for our application our country requires, right? So if we understand how this is done from a discrete level to a IC level, it will give an industry professional that this is the IC I am making and this is how it has to be integrated with the system to make the whole system work. And in this, I will point this one out a little bit because being from the industry, I have seen this. You think about a general microcontroller. The microcontroller will cost 100 rupees, 150 rupees, something like that, right? But if you make a converter out of it, okay, the system will be much highly priced than that. So the company can earn a lot. But in order to make a controller out of that small digital controller that you have made, so some additional circuits have to be put. So now you got the idea that what my integrated IC should have. So not only the controller that I have just made, but some peripheral circuits which have to be integrated in one single chip, and that becomes your application specific IC for your power management circuit. So this is what we will try to teach in the course.
So in short, you will be teaching how to put together or how to cascade or integrate at a system level various discrete components, and then how to miniaturize it and make it in a IC level format.
That's it. Correct. That is the point. Yes.
So how you feel that it is going to impact our the nascent the semiconductor industry, especially the kind of programs Government of India is undertaking to attract the multinationals to set up their production units in India, fab labs in India. So how you feel that this kind of initiative by PSA's office and through your support, IT Delhi support, how this is going to positively impact this nascent industry, sir, in India?
Okay, see, as such, IC is not used. Standalone use is not there. IC has to be used somewhere, right? And in power management IC is used to design a power supply to power electronic system. Right. So you can see that electronic systems are everywhere. We are trying to build all kinds of electronic systems in our country. In fact, those industries are being, let it be renewable systems, let it be EV systems, let it be consumer electronic systems. So all kinds of electronic systems are actually coming up. See, if all types of electronic systems are coming up, then we will require a power management ICs to build that, right? So therefore, when we are saying that we will have a fab, the fab has to make something. So this course will give an idea what the fab should make. Right, it will tell to general public that this is what we should make. Not only my course, there are many other courses that run around the country which will tell this fab that this is exactly what our requirement of our country is, and this is the IC that we should be building. I am specifically focusing on power management IC, but there are many other communication IC, RF IC which will be required. So these fabs will have their hands full because we have to be self-reliant. So I am only trying to answer that question from a power management perspective. There are other research groups and startups which are focusing on other aspects of electronic systems as well.
Right. So, sir, since the fundamentals in electronic industry and especially semiconductors, IC design, the fundamentals remain basically the same. So, how do you feel that going through this particular course, students will also get benefit or insights about the other similar courses, like as you said, the IC design for communications? So, do you feel that they will also have some advantage in these areas?
See, this is an entry level course. Yes. That has to be understood first. This is not a very advanced level course so entry level course means all the basic block diagrams will be there, right from MOSFET operation to how a current mirror is designed, to how a differential amplifier is designed, to how a two-stage op-amp will be designed. All these steps will be there. So in other words, what we are saying is that these basic blocks remain the same, but the specification of these blocks will change. But this fundamental of how the block will be
because
set. So
the operational amplifier or differential amplifier, comparators, they are essentially the basic building blocks of all the electronic components. Right. So once what I feel is that if they are going through this particular course and are having the kind of the foundational knowledge they can gain, they will be equally equipped to use it in the various other sectors.
Right.
So this will be beneficial to them as a whole VLSI industry, so to say, and specifically for the power electronics, power management IC design.
See, the reason I take the help of power management IC to propagate this
the whole idea
is because my experience in that field is a little bit better.
Yes.
I am more comfortable in that field. But I am pretty sure whatever blocks that will be using at an IC level are equally applicable to other fields.
Yes, like just as you said that, okay, you will be teaching the basics of how the MOSFETs will be biased, how they will be working in all the three zones. Then you will be taking for the basic amplifiers from the MOSFET. Then you will be upgrading to the basic diff amps. Then you will be upgrading to op amps. Then two-stage op amps. So this particular whole process is itself very fulfilling for any student or even a fresh working professionals in understanding how the circuits work at a very foundational level. And since you have also mentioned that you will be doing the simulations on TSMC 0.18 micron, so they will have a first-hand experience of how the ICs are designed and till the level of a tape out, what we call in our traditional language. So that till the tape out, they will be able to understand the design and the specification setting and the design of the basic components, which will be applicable in all the areas.
All the areas, right.
In fact, so to say, the electronic industry itself, they can apply their whole knowledge base.
So it's a very, I'll just make a little bit of a light-hearted comment here. So when I teach this class, one of the first question I ask is which region of operation the MOSFET works at. So they will always say saturation region. So then I will say that in power electronics it works in linear region, and in VLSI it works in saturation region. And both these things are combined in this PMIC. So that excites our students. Now how can a MOSFET work in linear region? Then they get excited, and so this is a very aggregated look of how electronic system work, and whatever a VLSI designer knows, we actually know at a little bit of higher power level.
Yes,
right. So that makes it.
And in fact, in a more broader way, like you just said that you will also be teaching how the MOSFETs will be working in the linear region. Right. So that itself is a very different aspect from what a traditional VLSI designer like us we are used of thinking. Right. For us, so MOSFET should always be working in a saturation region. So I think this whole knowledge level, they will be getting very enriched from the whole idea of taking things from the very basic MOSFET up to the level of the component, and then again you will be enhancing their knowledge skills to the block level, integrating the blocks, and the whole system comes into the picture.
I'll just make one single point just to clarify to our audience that this course will tell you from the block to implementation of IC in TSMC 0.18 process, right? So, but we will not go for tape out because we are not doing any tape out.
Yes, it's true. So but the design will be till that level that you can always do the final layouting and can go for the tape out. So till the just before the tape layouting thing, the circuit level thing you will be doing.
Designing.
Yes. So this
and we will be seeing in the system level simulation also it will work.
Yes.
Right. So in other words, like when I am designing a converter, I will use a standard op amp.
Yes.
Standard op amp, which is like a behavioral model of a op amp. Now I will replace that op amp with a actual two-stage amplifier. Right, differential amplifier, and I will show that it actually works. Right, so that is what the whole idea is. Right?
So, sir, what is your expectation from the prospective students, and what the students should expect from this particular course if they join it?
Okay, so let's start from what the students should expect. The students will get an overview of how power management ICs are defined and designed. Okay, from a block level to system implementation to IC implementation. Right, so that is the students' understanding. And what is important here is that this is a power engineer giving you an overview of power IC design. Okay, so that the students should expect. Okay, so if they do not have much knowledge on IC design, they don't have to worry about it. They are exactly like me when I started this course. With time, I learned it. Whatever I have learned, I will be impacting on them. And what is the expectation from the student? That is the second part of the question. The expectation should be that have patience. Try to solve all the questions that are being given, all the assignments that are being given, and we will have a lot of capstone projects. They should do that, and slowly they will learn everything. If they are thinking that by doing a 30-hour or 40-hour course they will become expert, no one becomes an expert in 40 hours. This will give you an overview or a starting point of what you should study and all the fundamentals required to know. Okay, so when I am saying that there will be a current mirror to a power electronics engineer, they will not know what a current mirror is, but after taking the course they will know.
Yes.
Right. So that means the course will give you all the fundamentals that are required, and after that it is our job to work on it and improve on it and make ourselves better. So patience is what I am expecting from students, and fundamentals what they should expect from.
Great, sir. Thank you very much, sir, for sparing time, your valuable time with us and telling us and also the prospective students of why this whole field is so exciting and what they will gain after if they join this course or any other such courses of this nature, and how they can be a part of this ever-growing industry in India and also global industry. Thank you for your time, sir.
Thank you very much.